Now we're going to take a look at confidence intervals for population means. We're going to break this into two different situations, if we know sigma or if we don't. For a population formula, the margin of error is given by, you multiply, if we know sigma, you multiply your z alpha over 2 value times, remember we did this standard deviation of the sampling mean back in the last chapter in section 6.5. So this says, what is the average credit rating for somebody applying for a credit card? Find a 90% confidence interval for the mean average FICO credit rating for scores of adults applying for credit cards. Sample information. We collected a simple random sample of 70 adults who were applying for the credit card. The mean credit rating of those 7 adults was 688, and we know the standard deviation of the credit rating for the entire population is 68. So our sample mean would be 688. Now our standard deviation of the population sigma is 68, but to find the standard deviation of the sample means, we take our old standard deviation of 68 and divide it by the square root of our sample size, which in this case is 70. So when I do 68 divided by the square root of 70, I get 8.13. So that would be our standard deviation of our sample means. Now, to the point estimate for our sample, just like it was p hat in proportions, it's going to be x bar here. So our point estimate is 688. So basically, I'm going to put 688 in the middle because that is my sample mean. And then I'm going to build a confidence interval by adding the error to the sample mean and subtracting it. Now we find that margin of error by finding our z alpha over 2 or critical value based on a 90% confidence level. Remember that we did that by looking at our confidence level, and it's 1.645 standard deviations away from the mean. So this critical value is 1.645. 645. And then we're going to multiply that by our standard deviation of our sample means, which is 8.13. So 1.645 times 8.13 gives me 13.37. So I'm going to add 13.37 to 688. And I get 701.37. Let's just round this to a whole number. And then I'm going to take 688 and I'm going to subtract 13.37. Whoops. Sorry. 688 minus, not my day. Let's try this one. 688 minus 13.37 is 675. So what we could say is, one way we could write this, we're going to write the two different forms of this. We could say we are 90% confident that the mean average credit rating of a credit card applicant is between 675 and 701. Or we could say we are 90% confident that the mean average credit rating of a credit card applicant is 688 with a margin of error of, let's say, 13.4. Now I want to show you that you can do this process in Excel. If we look at our Excel spreadsheet, we're going to go to the Estimations of Means tab. And you can see it's broken up into two sections. Let me zoom out a little bit. This left side over here is mean confidence interval for the population standard deviation sigma known. And then this side over here is the mean population, or the mean confidence interval with the population standard deviation sigma unknown. So we actually know sigma right here, so we could put our sample mean of 688, our confidence level of 0.90, our standard deviation, which was 68. That was not the standard deviation of the sample means, but the population standard deviation. And then our sample size was 70. And you can see we get the same thing, 675, right? Oops, sorry. So we got between 675 and 701, which is exactly what we got this way. Now we have a problem with this. In the real world, if we're trying to determine the population's mean, then we're not likely to already know the population standard deviation. And we can't just use the sample standard deviation. So to account for this less reliable value, we're going to make a bigger interval than we would have known than if we would have known the population standard deviation. The bigger interval, or the bigger distribution we're going to use, is called the t-distribution. In the next video, we're going to talk about what if you don't have sigma? What if we don't know the population standard deviation? We're going to talk a little bit more about the t-distribution and work out a few problems that way.